All right, so today we're going to be talking about linear programming. And so this is the method of finding a minimum or maximum value for some given quantity given a set of constraints. So for example, this is like one of those things that if you sell, if hats cost a certain amount and shirts cost a certain amount, how many hats and shirts do you need to sell to make the most profit? It's like a real life situation. So the blank blank contains all the points that satisfy the constraints. So constraints are like the stipulations. And so that would be the feasible region. And you can see over here the feasible region is that trapezoid in that figure. So it's going to look like that. So the quantity you are trying to maximize or minimize is modeled with an objective function. Often this quantity is the cost or profit. All right, let's go on. So here's our first problem. At what point in the feasible region, this should say maximizes P for the objective function P equals 2x plus y. Okay, so you have these constraints, and this is a multiple choice problem, but we're going to solve it the old-fashioned way and then circle at the end. So here are the steps to solving these problems. Step 1, graph all the inequalities. Okay, so let's do that. Let's graph the first one. I need to rewrite that. So it's x plus 2y is less than or equal to 5. Let's get it into slope-intercept form. Divide by 2, divide by 2, so y would be less than or equal to negative 1/2 x and then plus 5/2, which is 2.5. Okay, let's graph that. So we go to 5/2, which is negative 2.5. It's right in between. All right, and now we have to go down 1 over 2. So go down 1 to 1.5 over 2 to right there. Down 1 over 2. Down 1 over 2. Okay, let's try to make your line as straight as you can. Redo that. I cheated and used my line tool on this. Okay, and so we have that line. Now let's talk about which direction we need to shade. So we're going to be shading y is less than or equal to, so we will be shading below. And this problem is going to look really crazy, but at the end, in the next few problems I won't have you shade like this, but for now we'll shade like that. So now the next problem we need to graph is x minus y is less than or equal to negative or less than or equal to 2. So first thing we're going to do is subtract x from both sides. So you'll have negative y is less than or equal to negative x plus 2. Divide everything by negative 1. Flip your sign. So that would be positive x plus 2. All right, another solid line. So your y-intercept is at, oops, I messed up. This should be a negative 2 right there. Negative 2. So your y-intercept is at negative 2. And let's go ahead and graph it. I'm going to pause it and make a straight line again to make it look nice. Okay. And let's talk about which direction we need to shade. It's y is greater than or equal to, so we will be shading above this line. Okay, and now the next part is x is greater than or equal to 0. So that is going to be a vertical line, solid, at 0. Then which direction do we shade for that one? Well, greater than or equal to will be to the right. So we'll shade all of this. Told you it's going to be looking crazy. Last one. y is greater than or equal to 0, that is the x-axis. So let me try that again. And then let's go ahead and shade above because it's y is greater than, so we're going to be shading above. All right, now that our graph is looking good and crazy, let's talk about what the feasible region is. So I'm going to outline it in black. So the feasible region that has all 4 colors would be this right here. Okay, so it'd be that. So step 1 was graph the inequalities. We did that. Step 2 was form the feasible regions. I did that. Now the step 3 is to find the coordinates of each vertex. So let's label these vertexes to make it a little bit easier. Call this one A, B, C, and D. So let's list these down here. So point A is at 0, 0. B looks like, ooh, that's at 2.5. So 0, 2.5. C would be at 3, 1. And D would be at 2, 0. Okay, so we found the coordinates of each vertex. Now evaluate P at each vertex. So go back up to the top, and do you see this in blue, this objective function? So you're going to plug in these coordinates for that objective function up there. Remember, it was P equals 2x plus y. So I'm going to plug in 0 for my x and 0 for my y on this one. So the P will be 2 times 0 plus 0, which gives me 0. Okay, 2 times 0 plus 2.5. So that would be 2.5. The next one, 2 times 3 plus 1. 2 times 3 is 6, plus 1 would give you 7. And the last one, 2 times 2 plus 0 would give me 4. So the question was asking us what point maximizes. So we're looking for what maximizes. So that would be the biggest value if we're talking about maximum. So this would be the maximum for this objective function. And then how you answer this is at the point, and that point was 3, 1. So this was a multiple choice problem, and that would have been choice C. Okay, let's do another one. So this is just like out of the homework. So graph each system of constraint, name all the vertices, then find the values of x and y that maximize or minimize the objective function. So first things we need to do is graph. So you may not have ever graphed one of these compound inequalities. If it helps you, remember you can break these up. This is really like 2 inequalities. This is like x is greater than or equal to 2, and x is less than or equal to 6. So let's graph those. And we're not going to do all the shading, but just hold on. So let's graph them. We would have x is greater than or equal to 2. That would be a vertical line at 2. Let's see. Vertical line at 2. And which way are you shading on that one? Greater than 2 would be shading to the right. I'm not going to shade just yet. And then the next one would be x is less than or equal to 6. So that would be a vertical line at 6. Look like, oops. Tricky, oh man. Okay, got it fixed. All right, and so it would look like something like that. And then you're going to be shading less than or equal to 6. So you're going to be shading. I'm not going to shade it yet, but just watch. So if we were to shade this, we would be shading in between those two. Are you with me on that? Okay, just remember that. We're not going to do it so it doesn't look so crazy like the last one. All right, the next one is another compound inequality, and if you want, you can rewrite it as y is greater than or equal to 1 and y is less than or equal to 5. So what does this look like? These are horizontal lines. So a horizontal line at 1. Let me stop doing that. There's that one, and then there's a horizontal line at 5. Okay, so if you're shading, which we're not going to, just watch right now. So y is greater than or equal to 1, so that means you're shading above it, and y is less than or equal to 5. So if I were to shade this, it would be this region right here. So far, the only reason that's been shaded by both would be that square right there. I'm not going to shade it yet. All right, the last one, let's go ahead and shade it or graph it. So we need to subtract x. Let me switch colors. So minus x to both sides, and you have y is less than or equal to negative x plus 8. So that would be positive 8 on your x-axis, or y-axis, excuse me. And then let's graph. That was kind of an excessive amount of points, but that's okay. So this would be, kind of messed that up. Let's try that again. There we go. So here it is. And so which way am I shading for that one? Well, I'd be shading below it. So, because it's less than or equal to. So now, if I were going to shade the region that satisfies all 3 constraints, it would be right here. So this would be your feasible region. So this is your feasible region right here. So now the next step is to name all the vertices. So let's name them again. I'm going to do A, B, C again, and I think there's an extra one. So A, B would be right there, C would be right there, D, and E. So A, B, C, and C, D, and E. So let's label our points. We have A, which is at, what is that, 2, 1. B is at 2, 5. C is at 3, 5. D is at 6, 2. And E is at 6, 1. So let's go ahead and plug these in. Remember our objective function was this, the p equals 3x plus 2y. So we would have p equals 3 times our x value, which is 2, plus 2 times 1. And I'll just set them all up before I solve them. So p equals 3 times 2 plus 2 times 5. 3 times 3 plus 2 times 5. 3 times 6 plus 2 times 2. And then 3 times 6 plus 2 times 1. So solve, that would be 8. This one would be 16. I'm just going to write them down because I already know the answers. 22 and 20. So our maximum, because that's what we're trying to figure out, is the maximum. So the maximum would be at the point 6, 2, because that's the max. So the max is at 6, 2. All right, the next one, let's find the minimum for, this is your objective function, but we have to first graph all of these and figure out our feasible region. So let's graph it. We need to subtract x from both sides. That would give me 2y. It's greater than or equal to negative x plus 8. Divide by 2. So y is greater than or equal to negative 1/2 x plus 4. So let's graph it. It's going to be a solid line. And we are going to be shading x or y is greater than or equal to. So just for a visual, I'm going to erase this. We're going to be shading above it in a little bit, but not right now, but we're going to wait. Okay, and then x is greater than or equal to 2, so that would be a vertical line. Vertical line at 2. Let me make that a little bit longer. Okay, so look like that. And then we're going to be shading to the right in a little bit. We'll be shading to the right. And then the last one is y is greater than or equal to 0. So that again is just the x-axis. So looks like that. And then you're going to be shading above. So the region that has all three, that satisfies all three constraints would be this right here. Let me zoom in so I don't mess up. So all of this. Okay, so now how many vertexes? This is different because it's not an enclosed shape. That goes on forever and ever to infinity that way and to infinity that way. So don't think it stops at the edge of this graph because it goes on forever. So how many vertexes are there, or vertices are there on this? Well, to me, it looks like there's only 2. There's one here, we'll call it A, and then one here, let's call it B. So if we have the point A is at, what is that, 2, 3, and B is at the point 8, 0, and we're plugging it in for C equals x plus 3y, so C equals 2 plus 3 times 3, C equals 8 plus 2 times 0. That would give me 11, and this would give me 8. So which one's the answer? Well, this time the problem, remember, is asking you for the minimum. So since they're asking us for the minimum, we want the smaller number. So this one would be the minimum at the point 8, 0. That's how you answer it. All right, the last problem, this lovely word problem. I was talking about shirts and stuff. So you're screen printing t-shirts and sweatshirts to sell at Polk County Blues festivals and are working with the following constraints. You have at most 20 hours to make shirts. You want to spend no more than $600 on supplies, and you want to have at least 50 items to sell. How many t-shirts and how many sweatshirts should you make to maximize your profit? How much money, or how much is the maximum profit? So we have 2 questions. So what we need to do first is graph this. So these numbers are huge. You won't have one like this on your test. I just wanted to show you this problem because it is a real life situation. I'm going to go over to Desmos really fast and graph it and then insert it on this really fast just so we can see it. If you were in class, I would have you graph this manually on Desmos, but to save time, I'm going to pause the video, go graph it, and then bring it back. Okay, so here is our graph. Oops. Oh no. Okay, this might be bad. Let's wing it. So we have the points right here. Let's do black. I know it's hard to see. This point right here is 75, 15, and this point is 120, 0. I'm going to call this A, B, C, and D. All right, let's go ahead and start labeling these points. So I have A was at 50, 0. B was at 25, 25. C was at 75, 15. And D is at 120, 0. Let's go ahead and plug them in. So the point would be, so remember the objective function is right there. So I would have P equals 6 times 50 plus 20 times 0. On this one, P would equal 6 times 25 plus 20 times 25. For C, it would be 6 times 75 plus 20 times 15. P would equal 6 times 120 plus 20 times 0. So if you solved all of them, I will just tell you this one's 300, 650, 750, and 720 if you solved all of them. So we are looking for the maximized profit. So if you, what this means is your maximum profit, let me see if I can do this. Oh, there it goes. So your max profit would be by selling, it would say, so your X value, this one's our max profit here. Remember it says right here, your X is your t-shirts and your Y is your sweatshirts. So your max profit would be by selling 75 t-shirts, because that's your X value, and 15 sweatshirts. And so, and that would how you make your max profit, and your max profit would be $750 because that's what we got there. All right, that is it for linear programming. Thank you for watching. Hope you enjoyed Unit 1.